Hi, this is the last video. It's over sections 7.5 and 7.6. It continues the discussion of how to produce data. So remember last time we talked about sampling and in particular talked about errors that can result from improper sampling. Let's continue the discussion here and talk about experimental design. A context that I'm going to use is a series of scenarios all centered around this case study. How could a pharmaceutical company demonstrate to the FDA, the Food and Drug Administration, that a new drug helps treat depression? So if you didn't know this, you need to understand that when a company like Eli Lilly develops a new drug and wants to put it on the market, they have to demonstrate to the FDA that the drug is both effective and safe. That is, it does help treat the condition for which it's designed and the side effects are minimal. So suppose and it's the drug company's responsibility to conduct those tests under verifiable conditions and report to the FDA. Suppose the drug company finds 1,000 people, half men and half women, who are suffering from depression and who are willing to take part in a 6-month medical study. So usually clinical testing of drugs begins with animals and then proceeds to human volunteers who are paid for their willingness to take the risk. And then finally it's approved for the general public. Alright, let's assume that the time frame is correct. There may be some discussion about whether 6 months is the right time frame to study depression, but let's assume that that's okay. The issue becomes, how are we going to conduct this experiment? So here's my first scenario, and then I'm going to propose a series of 6 or 7 here. When I teach this course in class, I have the students get in groups and I present these one at a time and they discuss what they think is good or bad about these particular incidents. So you may want to pause the video and think yourself. Experiment number 1. Have psychiatrists prescribe the drug to all 1,000 people, then ask the people if they feel better. Is this likely to get good data or not? And if not, why not? Well, this is a bad way of conducting an experiment. Depression is a psychosomatic condition. That is, it's a mind-body dual experience. So to some extent, the ability of the patient to get better and his or her perception of doing so depends on how much he or she believes it's likely to happen. And so if you prescribe the drug to the 1,000 people and then ask them if they feel better, it becomes a very subjective experience. If they think they're going to get better because they are taking the drug, then maybe they will get better even if the drug wasn't what helped them. Or conversely, if they have suspicion about this drug, then even if the drug did help them some, they may not be willing or able to recognize that. So, not a good idea. Well, okay, how about this then? Have psychiatrists prescribe the drug to the 500 people who have suffered from depression the longest, then have them compare those people's health with that of the other 500 people who did not take the drug. So here we're starting to get some better components brought in. Not all of the people are going to take the drug, and the reason is we want the people who do take the drug to be able to compare them with some people who did not. But the method of choosing these two groups is bad. The people who have suffered from depression the longest may be the ones who are suffering from depression the worst, or they may be on the verge of getting better anyway without treatment, or some other scenario where the length of the illness has some bearing on the severity of the illness and its progression. We would really like the two groups to be as alike as possible, and this doesn't do it. Okay, randomly choose 500 people and have them take the drug and the other 500 people don't. Then have the psychiatrist compare those who took the drug with those who didn't. You see how this partially fixes the problem that was mentioned in experiment number 2. Now the two groups should look pretty much alike because they were chosen randomly. And so they go into the experiment being very similar to each other, and then one gets the drug and one doesn't, and now a comparison between the two groups has a better chance of working. There are still some problems. And that will be brought out by this fourth one. Have psychiatrists prescribe the drug to the 500 women and a placebo, or so-called sugar pill, to the 500 men. Then have the psychiatrist compare the health of the two groups. You see, in the previous case, in experiment number 3, the people who took the drug obviously knew they were getting it, and the other people obviously knew they were not getting it. And so there's still this mental possibility of influencing the results. The perception of the person himself or herself may influence how he or she feels. Whereas here, the sugar pill looks exactly like the actual tablet containing the drug, and so if the subjects are not told that women get the drug and men get the sugar pill, then they won't know whether they're getting the actual medication or not. And now their perception about how effective this drug may or may not be doesn't play into the outcome. But the problem now is that we're talking about depression, and as you probably know, depression affects men and women differently. So in particular, women are more likely than men to suffer from clinical depression, and so these groups are not alike as we head into the experiment. So we're back to problem that the two groups look different. Well, okay, let's randomly choose 10 people and have them take the drug, and another randomly chosen 10 people get the placebo, and then we'll compare. So now we have a group taking the drug, a group taking a placebo. They're randomly chosen, so we don't have this gender problem, difference in gender problem anymore. And seems like that should work better, but now I think you probably have another objection. We have 1,000 people available who are willing to take part in this experiment. 10 people who do and 10 people who don't take the drug are small numbers. And so it's possible that we'll get some random effects just due to the small sample sizes here. And so we won't be able to have very much confidence in our results with these small numbers. And so let's try. Randomly choose 500 people and have them take the drug. The other 500 get a placebo. Then compare the results. This is getting close now. We have large numbers. We have two groups that are randomly chosen, so they look pretty much alike before the experiment. Nobody knows whether they're getting the drug or the placebo, so the psychological effects have been presumably canceled out. There's one more thing we should do. This is depression. You can't just hook someone up to a piece of test equipment to measure depression. You can't put them in a MRI scanner or take their blood pressure or something like that and measure depression. Depression is evaluated by subjective opinion of a doctor. And so here would be a better way. Same as the previous experiment, but instead of having the psychiatrists who are prescribing the drug and monitoring the patients diagnose, we'll have an outside group of psychiatrists do the diagnosis about who is and is not getting better. And this is designed to try to counteract the subjectivity of the doctors. Before we talked about the subjectivity of the patients, now the subjectivity of the doctors. The doctor who's working with this drug may or may not believe that it's going to be effective, and he then may or may not have an opinion ahead of time about who will or will not get better. And so then he comes, for example, walking into the room and says, "Oh, you look like you're doing a little better." Or And that may be to somebody who's getting the drug, and then to somebody who's he knows is getting the sugar pill, he may come in and say, oh, well, we still have some time left. Maybe it'll start working next week. And these kind of subtle comments can influence the patient then. So in actual experiments, you never have people who know who are getting the drug and who are getting the placebo to actually have patient contact. Number 7 here now is a pretty good design for an experiment. So a valid experiment has to have at least these 3 components. It has to have a separate control group and a treatment group. The control group gets the placebo somehow. That may mean different things in different types of situations, but in our example it was the sugar pill. And there has to be a treatment group who actually get the experiment or get the education, the teaching given to them if it's a educational experiment, and so on. The subjects have to be placed into these 2 groups randomly, and the groups have to be sufficiently large. These are expensive to do in practice. It's complicated to set up all of these 3 things, and it costs the drug companies or whoever else is doing the experiment lots of money. The reason you need to do this is we have an interest in showing cause and effect. We don't just want to know that there's a relationship between 2 things going on, but we would like to know that taking the drug improves the condition. So why must there be a control group? Well, we have to let's see here, to counteract the effect of other possible causes of improvement in the patient. Patients. I'm doing this discussion still in the context of the patients being treated for depression. So there are other factors that might influence depression. For example, exercise or time of year and the amount of sunlight or stress in people's lives. And so what you want, again, is a control group that's alike, just like the treatment group, except in the matter of getting the drug. And if you have that, then you reason as follows. Because the treatment group got better more often than the control group, the patients in the treatment group got better more often than the patients in the control group, and everything else about the patient's environment was the same, then we're entitled to conclude that the drug helped improve the patient's health in the treatment group. There has to be a sufficiently large control and treatment group. Why? So that randomization will allow the control and treatment groups to be evenly assigned. What I mean is, suppose you have a group of men and a group of women, and you decide to choose 3 of each for a control group and for a treatment group. With such small numbers, it's quite possible that all 3 men that are all 3 people who are chosen for the control group will be men, and all 3 people who are chosen for the treatment group will be women. That can happen with small numbers. But if you have 1,000 people, there's virtually 0 chance that all of the treatment group will be women and all of the control group will be men. Sufficiently large groups ensures that randomization actually works and splits the control and treatment groups apart in ways that are alike. Okay, there's another technique that is often used in the design of experiments. Those variables like gender and age and income and time of year and so on, variables like this can be highly significant in whether patients get better, um, whether they overcome their depression or not, and how quickly they do so. Those variables are called lurking variables. They are variables that influence the results, but they're not the drug itself. They're not variables that we're interested in. We wish they would just go away, but they are lurking in the background. One of them, gender in particular, is easy to isolate. We just obviously know who's male and who's female, and furthermore, we expect the gender variable to be highly important in terms of its effect on the results. So what's often done in a study like this is we'll take our subject pool, and before we even begin, we'll split them apart into the men and the women. And then for the females, we'll randomly, this part is then random, we'll randomly split the women into a control group and a treatment group, and likewise we'll split the men into a control group and a treatment group. And we'll conduct separate experiments. Basically, the women will be treated and analyzed at the end, and we'll make some judgment about whether this drug is or is not effective in treating women for depression. And likewise, we'll make some separate assessment about whether the drug is effective in men. At the very end, then we might attempt to bring these results together, or we may just keep them separate. In drug studies, subjects are almost always broken apart by gender. In other situations, we may break people apart in terms of socioeconomic status or ethnicity or political party. It depends on what we're trying to study as to what lurking variables might be important and how we might want to block. Here's another term you should be familiar with, and it's back to the case of the doctors diagnosing depression or other doctors diagnosing depression. In medical experiments and psychological experiments, neither the patients nor those who have contact with them who know who is actually getting the treatment and who's getting the placebo. So there are the patients, then there are the doctors who are monitoring them and prescribing the drugs, and then there's a group of researchers, and there are people who are diagnosing them, an outside group of psychologists who are diagnosing whether they got better or not. And then finally there's the team of researchers who is actually conducting this experiment. That team is the only group of people who know who got the treatment and the placebo. Everybody else is blind, both patients and doctors. That's the double part of the word. Everybody else doesn't know. The reason for that, again, is to avoid psychological impact of people believing they know what's going to happen and then subconsciously making it happen. Let's discuss experimentation versus observation. Here's a definite fact. It's been observed many times that people who eat lots of broccoli tend to live longer than those who don't. What can we conclude? In particular, can we conclude that eating broccoli makes you live longer? So first we have to say, okay, it is observed. How so? Is this a designed experiment in the sense that we were talking about, with a control and treatment group, random assignment, large sample size, and so on? And the answer is it's probably not, because for a dietary longevity study like this, you have to follow people for decades in order to find out how long they live. And you just can't control people. You can't tell certain people that they are not allowed to eat broccoli and other people that they must eat lots of broccoli. Nobody has the power to order people around like that. And so it's virtually impossible to do a designed experiment, a fully scientifically designed experiment in a case like this. And therefore, the lurking variables, possible lurking variables, haven't been controlled, and therefore we cannot conclude that it was the broccoli that did it. What can we conclude? Well, we cannot conclude the broccoli was what made people live longer. For example, here's another possible explanation. I would guess that people who eat lots of broccoli also tend to smoke less often, less frequently than average. And smoking is bad for your health. So maybe the scenario is people who eat broccoli tend to be health conscious. They know they're supposed to eat fruits and vegetables. And people who are health conscious tend not to smoke. And people who don't smoke tend to be healthier and live longer than those who do. So perhaps it has nothing to do with the broccoli itself. That would be a case of a lurking variable, smoking, and psychological health choices. And this setup did not eliminate those lurking variables, so we can't say much. And so, as an example that I do in class, I sometimes ask people to design an experiment to tell if people can tell the difference between different types of cola by taste alone. So pour some brown juice in one cup and in another cup and have people taste them and see if they can tell the difference between Coke and Pepsi and Diet Coke and Dr. Pepper and Diet Dr. Pepper and so on. And make this be a designed experiment or as close to it as you can. So there has to be some sort of double blinding going on, some sort of control group going on. For example, some people should get the Coke first and some people should get the Pepsi first, because which drink you taste first might have some bearing on how you answer. And so it's a very complicated problem, but a very important one. These are how scientific studies are done, and it's good for you to have some background into the complexity of the situation. Alright, as I said, this concludes the videos and presumably the course itself. So I've enjoyed giving them. I hope they've been useful for you, and best wishes on the final.